Hi everyone, good morning. We're going to be going over the steps in the glycogen breakdown pathway, reaction, whatever it's called. And in this, of course, this pathway is named the glycogen breakdown, aka sorry about that highlighter already, glycogenolysis. And we're going to be, of course, working with glycogen. Glycogen is just a bunch of glucose units repeated, and there's some branching. You have alpha 1, 2, 4 linkages in this molecule. However, for every 12th unit, you get to an alpha 1 to 6 linkage, and this causes the branch. There are some enzymes involved that are going to deal with these branches, but let's get started on the pathway itself. And we're going to draw some really nice art pictures too, I guess, to explain it. All right, so the first step would be taking the non-reducing ends of the glycogen. Again, glycogen has all these branches. We have a ton of non-reducing ends in this molecule, so you have a lot of areas to work on. So we're going to be taking those non-reducing ends. We're going to be using this enzyme called glycogen phosphorylase. And when we take glycogen phosphorylase on these non-reducing ends, we are going to get a bunch of free units of glucose 1-phosphate. We're going to continue cleaving until we reach 4 units away from the alpha 1-6 branch. So what does that look like? Well, let's draw a little diagram. Right, so there's our alpha 1-6 right there. So this is going to be the alpha 1-6 branch, and with our enzyme, our glycogen phosphorylase, we're going to go to the non-reducing ends, and then we're going to keep cleaving and creating these glucose 1-phosphates. So what does that look like? Well, let's just start cutting them off, shall we? We want to get to 4 away from that linkage, the alpha 1-6 linkage. So 1, 2, 3, 4. I think we're at a good stopping point, so we're going to stop right around here. That's where we're going to stop. So all of these are now glucose 1-phosphates. Okay, step 2. We're going to be using something called the debranching enzyme. And this debranching enzyme has 2 functions. First, we're going to have its transferase function. And for simplicity, I am just going to copy this picture over and now erase what we've cleaved away, all those free glucose 1-phosphates and their alpha 1 to 4 linkages. All right, so debranching enzyme acting as a transferase. What's going to happen here is that we're going to transfer a block of 3 units, and they're going to be moved to the non-reducing end of the chain. All right, so which of these glucose units are the 3 units in question? We're going to actually take those ones I just circled with the moving tool, and we're going to just move them over at the end of that non-reducing branch right there. So again, 3 units are moved to the non-reducing end. Once that's done, we're going to go to step 3, still with debranching enzyme. And then now it's going to act as a glucosidase if we go to our picture, we're going to have something that looks like this. Let me copy it over. And we're going to erase a few things here because we moved those 3 glucose units over, right? So there's going to be these 3 new ones at the bottom. This debranching enzyme acting as a glucosidase is going to cut that free glucose right here. This is going to become a free glucose. That's the result. Free glucose. We're going to cut that off, so let's cut that linkage right there, and now we have our free glucose. It's that last alpha 1 to 6 remainder on the top strand. All right, the next step will be involving our previously cut in step 1, these glucose 1-phosphates. So we're going to have glucose 1-phosphate. We're going to be using phosphoglucomutase as the enzyme. And we're going to be transforming it into glucose 6-phosphate. On this enzyme, we have an important serine. This amino acid, if it's missing from the enzyme, then it's going to be inactive. So we need that serine there for this to work. Step 5, there is a step 5 in the liver of this process. We're going to be taking our glucose 6-phosphate and we're going to be transforming it back into regular glucose. This is going to again be in the liver. And the enzyme that we're going to be using is glucose 6-phosphate. I should say glucose 6-phosphatase. I should write it out. There we go. Right, so that's going to be the enzyme, and we get to this glucose here, regular glucose, and that's going to just increase the blood glucose level. All right, so those are the main steps of breaking down glucose. Let's go and talk about some of the regulation. So we were talking about glycogen phosphorylase up in the first step. And we have regulation of muscle glycogen phosphorylase to also cover. Let's write that first step again. So step 1 in glycogenolysis or breakdown of glycogen, we are going to have the non-reducing end. And it's going to be worked on by the glycogen phosphorylase. And we're going to cleave off the glucose 1-phosphates until we are 4-way from that alpha 1-6 branch. Right, so that was step 1, right? So about this glycogen phosphorylase, we actually have 2 kinds. A is the active version, while B is the less active version. When glycogen phosphorylase is phosphorylated, this is going to be its active state. The B version could get phosphorylated, and it will become active. Some things cause it to become active again. So we have glucagon. Remember, glucagon is like glucose is gone, so that's from the liver. This is going to help activate it. And we could also have epinephrine. For that fight or flight, we need to break down glycogen in order to get to glucose and break that down for more ATP. All right, so this regulation, it's kind of like one of those GPCR type deals where we're going to get some ATP and we're going to be using adenylyl cyclase. to make cyclic AMP, or CAMP. Once that is made, we're going to be having this pKa get activated. Okay, so pKa plus calcium are going to then, let me write this down, pK plus calcium will then activate our phosphorylase B kinase. These two together will activate a kinase known as phosphorylase B kinase. When phosphorylase B kinase is activated, this is going to activate the glycogen phosphorylase B into glycogen phosphorylase A. There we go. Sorry about that. Right, so when glycogen phosphorylase B becomes activated by phosphorylation, it becomes A. Remember, this is the active form of that enzyme. And when that happens, we're able to then go through the process of breaking down glycogen. We have glycogen acted on the glycogen phosphorylase A. That creates glucose 1-phosphate. We have 10,000 molecules there, and then those could either go into glycolysis. They need to be, of course, transformed by the phosphoglucomutase to go into glycolysis, or they could be reverted to glucose, regular glucose, in the liver. And that's going to require the glucose 6-phosphatase. That's only in the liver. So that's kind of how we have a cascade. Remember, we have cascade. A cascade is involved in the regulation. We also have some other control mechanisms. Again, we talked about calcium. That's going to be activating our phosphorylase B kinase, as stated here. AMP is going to drive this forwards. It's going to drive the activated phosphorylase, and it's going to speed up the release from glycogen. It's going to speed up step 1 as well. ATP is going to, however, block it. We also have this other enzyme here, PP1, but then that's kind of for the next step, which will be glycogen making. So please stay tuned for that later on. It also has a play in here, but basically when PP1 is present, it's just going to inactivate phosphorylase A and it becomes B, so it gets less active. All right, that's going to do it for the steps, just the steps only of glycogenolysis. Please do something nice for someone and take care.